Middle 91%. So first, how the hell do you draw that? So there's got to be two z-scores that bound the middle 91%. So it sounds a lot like an empirical rule, but it can't be one of those numbers. It's got to be some funky number, right? So within two standard deviations, well, actually we know it's about 1.96, but it has 95% within it. So 91% is going to have to not quite as far out, so that it has less percentage in the middle. So it's going to be something like this. Now the chart would not understand that number at all. Not for my situation. If I look up 0.91 in the chart, we already know what we get. And that's not my situation. So what the hell do I do? Why does the chart have a problem? What's the only thing the chart understands? Areas that are below a z-score, right? How many z-scores do I want up here? Two. How much area is below either of them? How much area is below this one here? 4.5, right? Because there's 91% in here. How much is outside? 9%. How much is on one side? 4.5%. So you look up 0.045. Get as close as you can. To be back here on the negative side, right? Man, my picture's really off-center, but oh well. 0.045. The closest I can get. What's the closest you can get to 0.045? I love it. 169 is, where we go? 169 is 455, but 170 is 446. That's closer to 45, so it would be 170. What do you think this z-score is going to be? It's got to be positive because I said the middle 91%. It's got to be symmetric. But if you want to be sure, you can look up how much area is this? Yeah, 0.955, right? So if you look up 0.955, you'll get positive 1.7, but you don't have to do that. It's symmetric. It's got to be. It's the middle, so it's got to be whatever this is. It's the opposite sign. Negative 1.7 and 1.7. Now that's going to become really important. If I was looking, let me ask you guys, if I was looking for a specific data point, and I was thinking about this like casting a net out. I stand in the middle and I cast the net out. If I do it like this, how confident am I that I caught the data point that I'm looking for? I was thinking about like trying to catch fish. Even though I hate fishing and I don't eat fish, it's still a good visual, right? If I cast a net, I want to catch a specific fish. How much fish have I caught? What percentage of the data have I caught? 91%. So how confident am I that I caught a specific data point, a specific fish? I'm 91% confident. That's what chapter 7 is all about. That's all it's all about. It's silly. It's going to be really crazy easy after what we've been through. All right. So how many guys have... yeah, what's up?
So I get where you get the 0.045 from, because you have to finish up for the 100%, but find the z-scores bounding in the middle, so then what do you do the 1 point, like that minus the...
So all I care about is getting a way to find these two z-scores. The chart could not work with that number, of course, right? So you know why, or you know how I got this number. Do you know why I got that number? Because now, what's that z-score? It's the z-score that has that percentage below it. The chart understands that totally.
So all you're finding is the two z-scores. Okay.
So I want you guys to realize it's not cheating. If I say find the z-score that has 11% above it, all right, well, I can't find that directly from the chart. The chart only understands here, well, what area is below it then? 89. So if I look at 0.89, you didn't change the problem. The stupid z-score is still in the same place. It's still the same z-score. You just get the number that the chart will understand. Same thing I did up here. I didn't change the problem at all. I just said, well, if that's true, then this is true. And that's what the chart understands. Let me go look it up. Yeah.
Could you do 6
6(1)(b)?
Yeah.
Okay. So 6(1)(b), it says find the probability x less than 22. And this is the one where I've got 88% probability of thinking that the DNA tests are very reliable. I've selected 24 adults. So what I'm trying to do is generalize that whole at least one is 1 minus none. I want you to understand that because that happens a lot. But it's not the only type of thing that could happen. How many calculations would I have to do for this directly? What is less than 22? 21, 20, 19, 18, down to 0. So hopefully you're with me when you say, screw that. Right? What's the opposite of less than 22? Greater than or equal to 22, right? If this includes 21 to 0, what they leave out? 22, 23, and 24. That's much fewer calculations. And in fact, on 6(1)(a), I already made you find the probability of 22. So now you got to find the probability of 23 and the probability of 24. Add those all up and subtract from 1. Because the idea, the general idea is if I have a probability, but I know the opposite one, I can find that probability by doing 1 minus the opposite. In this case, the opposite situation is a lot less work. So hell yes, I will do it. And by the way, you can use binomial PDF, you can use normal CDF, you can use all that crap to check your work. It's not your work though. I will give the points to your calculator, and your calculator will pass. Yeah?
Why did you choose 3? Why did you choose 3?
Oh, I didn't choose. It's totally set up by this problem. 22 is way too much work because it would be 21, 20, 19. What's the opposite? Realizing that I only have 24 people. The opposite would be 22, 23, or 24. Right? We always have that cap of the total number of people I'm looking at. So at least one, I almost always will do 1 minus none because it's almost always going to be less work. But if I had 80 people and I want to know the probability less than 79 of them do something, well, I'm going to turn that one around too. It'd be 1 minus 79 or 80. That's a lot quicker than 78, 77, 76, all the way down to 0. Screw that. So the idea is more general. It's any time the opposite probability is easier. Hell yes, I will do it then. That only makes sense because I'm allowed to. Maybe. So to do this one, and you'll have this answer from part A. This one will be 24 people choose 23. So I have 23 successes. How many failures? Right? Probably success is 0.88. So I have 23 of these. How many failures? How many people do I have? Yeah, I must have just one because I got 24 total people. And
That's for A, right?
well, A would be probability 22. Right? This part A says 22. So you'll already have that answer. You just have to do a formula for 23 and a formula for 24. Add them, subtract from 1, you're done. Now to check this, maybe we should do this. Has everybody got the formulas here? All right. It's on there too, so. All right. So help me out. What's the probability of 22 successes here? So N is 24 people. 88% chance of success. So of course, where to get that number? What's the chance of failure? 1, 2. All right, so the rest. So how does this formula set itself up? I got 24 people. I want to choose 22 of them. And I want those 22 people to do this. So how many people do I want to fail? 2. And just throw that in the calculator. Here's where that second enter. If you do a problem, then hit enter. It gives you the answer. Hit second enter. It'll show the last thing you put in. You can just go back and change that to 23, 23, 1. And then hit second enter and change it to 24, 0. Yeah?
So were you saying that on the test we can't just put that in to show?
If you want to check your work, you can do binomial P or C. P for a particular value. Binomial PDF. You can do that and it'll be N, P, X.
No, that's not what I'm saying. I'm
Okay.
just saying that, like on the test, when we enter it in, like you're putting for choose all that, and then we get the answer, do we have to like show our work somehow? Like,
No. Your work would be setting the formula up.
oh, okay.
Yeah. Now, what's really interesting to me, sometimes people set the formula up entirely wrong, and then they get the right answer. I'm like, that's neat. Yeah.
So with a PDF, that was for a particular value, right? Looking for 22. The CDF would be with it.
Yes. And the CDF would give you this answer directly, because you use CDF up to 21, so it's a really good way to check your work. Cool.
But on the exam, you're going to want us to find each individual probability.
Yes.
Add them together.
So obviously, I'm not going to ask you one where you got to do 30 of them. That would be slightly insane. At the most, I'd ask you to do like this one, a couple of them. Yeah. Okay. So I gave you a couple problems on here that both dealt with binomial probability. Number 1 is also binomial probability one. It's a little more straight to the point for number 1. How you guys doing at number 5? You guys try that one out?
For 1D, would it just be 25%? If it's 1 minus none, so it's say 1. Can you do it?
The reason, I really want you to understand this, that 25% number only works for picking one person. Most probably one person does something. On part B, I'm asking if we picked 20 students, what's the probability that at least one of them know where it is? So 25% is the probability that any Grossmont student by themselves knows where it is, right? So there's no way that could possibly be the answer to that one.
These things 1, 2, 3, 1 or more, right?
So for 1B, probability that x is bigger than or equal to 1, right? That's the probability of at least one of them knows where it is. And like somebody just said, it would be 1, 2, 3 up to 20. So you could either do all those calculations.
So don't you have to multiply by 20?
Well, set it up. What's this equal to? It's equal to 1 minus probability of none. And how now here you just what's the probability of none? 20 people. Choose none of them to know where it is. So how many do you want to know where it is?
0.
And how many do you not? 20. Because again, you can go directly, and I love this. I saw a few of you guys doing this on the take-home, I think it was. I don't need to set all this stuff up. 20 choose 0 is actually 1. How many ways is there for me to choose nobody from 20 people? I don't choose them. There's one way. And anything to the 0 power is 1. So if you think about it, if I got 20 people all in a row and I don't want any of them to know where the Casbah is, each of them would be 0.75 and 0.75 and 0.75. So how many 0.75s would I have? 20. But the binomial setup kind of keeps you straight. It doesn't let you forget that power. It can't just be 1 minus 0.75. That's probably that one person won't know where it is. I want to know the probability that nobody